lambda qi squared. Yeah, remember this lambda is your regularization factor. The higher lambda, the more you want to penalize the model for complexity. Again, we've seen this in past lessons. There's no difference here. Alright, so if you look at this one here, yeah, this function is not convex and it has two unknowns. Yeah, it's P and Q. Yeah, two unknowns. So one option is that you alternate between P and Q, and this is then called alternate least squares, ALS. Okay. Basically what it means is you update P and you keep Q as a constant, right? Next iteration you update Q and you keep P as a constant. So you alternate between P and Q. In this way your problem becomes quadratic. Yeah? One of these has no impact and you will have a nicely quadratic cost function which you can use to do gradient descent on. Now it's not very likely you will come across ALS because this is really when you deal with large data sets, really big data with Spark machine learning. So I wouldn't worry too much about it. Yeah. There's also another few of parameters you can add. There's many. An example is user bias. Yeah? User bias. What is user bias? Well, it's a bit similar than calibration or performance reviews. Yeah? You can have a boss, and you have these bosses that are very difficult, and when you score 3 out of 5, you've done a great job. You have other bosses that will always give you 5 out of 5, the maximum of the points. That creeps in here as well. Yeah? So you have user bias, which again you can correct for. Yeah? There is time effects. I mean, there's a lot of other parameters you can add here. Yeah? But this would lead us too far. Most important thing is that you understand how this now works. And it's quite simple. Now, neural networks, we will not discuss too much. Basically what you're gonna do is, in a neural net you have an input, right? Several layers, and then you have an output. Out, in. Deep learning neural networks mean that you have multiple layers. Yeah? But basically the principle is the same. You will work with your training data here. You will see where you come out and look at what your error is at the end. And if there is an error, you will go all the way back and adjust your inputs. Yeah? This algorithm of going all the way back, this is called back propagation. Back propagation. You'll hear plenty of back propagation once we deal with neural nets. But this is all I want to say about it. Yeah? Just the software here, you can use Google's TensorFlow. Yeah? It's great, great machinery. Supports multi-core distributed systems. You have an API like Keras API for TensorFlow. You can use Python. It was actually developed or released by Google in 2015. Yeah? So it's quite recent. Alright, this was it for recommender systems. There will be no coding session here. And let's now close that chapter of shallow learning. The next chapter we will look at unsupervised learning. Thank you. Bye.